Good morning, everyone. This is one more session with respect to Linux system programming. In this session, we need to talk a little bit more about message queue concept. So before starting with the today's session, if my voice is clear, able to see the screen properly, please type 1 in the chat box. If my voice is clear, able to see the screen properly, please type 1 in the chat box. Okay, thank you very much. If you're able to recollect, what is the discussion happened in the last session? Will you agree? In the last session, we are trying to understand 3 different things which is related to message queue only. First one is we are trying to understand how to create a message queue. Whenever you are creating or whenever you are opening the message queue, what are the points you need to take care? Second one is whenever you want to send a message, what is the format of sending the message in the message queue that we are trying to understand? What is the format to send the message into the message queue that we are trying to understand? Third one is how to receive the message from the message queue. We are trying to understand it. Again, in the first part, we are trying to understand how to create a message queue and what are the things we need to take care when we are creating or when we are opening the message queue. In a second part, how to send a message into the message queue. When we are sending the message into the message queue, what are the precautions, what are the things we need to take care? How to receive the message from the message queue. So those things in a third part, we are trying to understand it. Today also we need to continue with this. Today some more properties about the message queue we need to discuss it. So before that, if you see this program, in the last session, whatever we discussed it, if you see this program, in the last session, whatever we discussed it, if you see this vi p1.c, now tell me, here for this program, we are taking the input from the command line. Will you agree? In this program, we are taking the input from the command line. Yes, sir. We are taking the input from the command line. What are the inputs we are taking here? One is type of the message and another one is type of the message and another one is the message. One is the type of the message. Will you agree? In this IPC mechanism, one condition is whenever you want to send any message, so every message should have one type. Again, please try to reply it. In this IPC mechanism, whenever you want to send any message, every message should have one type. So here, example number 2 as the type of the message is an hello. Second thing is, whenever you want to send a message into the message queue, one standard format you need to follow. Second thing is, whenever you want to send any message to the message queue, you need to follow one standard format. What is the format? What is that format? In that, the first will be the type of the message. Well, you need to declare one structure. In that structure, the first member should be long message type. First member should be long message type. Second member should be the data. If you accept the statement, type 2 in the chat box. First member will be long M type. Second member will be whatever the data you want to. So in this type of IPC, you need to declare a structure which should contain only the 2 members. The first member should be message type and the second member should be data. Second thing, if you come to this program, in this program, this key plays a major role. Will you agree? In this program, this key plays a major role. Every message queue is recognized with one key. Every message queue is recognized with one key. Every message queue is recognized with one key. So whenever you want to open a message queue, you must and should know the key, then only you can open the message queue. Whenever you want to open the message queue afterwards, if you want to send a message into the message queue, you must and should know the key. Now, can I say this MSG get function is useful for opening as well as creating the message queue? This MSG get function is used to open as well as creating the message queue. Okay. So when you open or create a message queue, will you agree you will get one ID? Whenever you open or you create a message queue, you will get one ID. What is the use of this ID? What is the use of this ID? Can I say this ID is used to send a message into the message queue, receive the message from the message queue? Will you agree? This ID is used for sending and receiving purpose. So this is just for opening purpose. Key is only for opening purpose. After that, sending and receiving purpose, you need to use this ID. Sending and receiving purpose, you need to use this ID. After that, whatever we are getting from the command line, we are storing into the structure variable. Again, whatever we are getting from the command line, we are storing into one structure variable. And we are sending it. And we are sending here. So what is the first argument of MSG send? What is the first argument of MSG send? What is the first argument of MSG send? ID. Second argument, the address of the structure variable. Third argument, the size of the data. Size of the data. And the fourth argument is a flag. For the time being, I am putting the flag as a 0. Fourth argument is a flag. For the time being, I am putting the flag as a 0. Fourth argument is a flag. For the time being, I am putting flag as a 0. Now, one thing I need to ask you, in this IPC mechanism, is there any rule that when the transmitter is transmitting the message into the message queue, receiver must and should be there? Right? One thing I need to ask you, in this IPC mechanism, when the transmitter is transmitting the message into the message queue, is there any rule that receiver must and should be there in that? Answer is, will you agree? No. Transmitter can transmit the message, receiver can come afterwards, receiver can receive it. So yesterday we written the receiver program also. Yesterday we written the receiver program also. So in this receiver program, what is the input we are taking from the command line? In the receiver program, what is the input we are taking from the command line? In the receiver program, what is the input we are taking from the command line? In the receiver program, what is the input we are taking from the command line? Can I say message type? Will you agree in that message queue, there may be multiple messages. Every message is having one type. In that message queue, there may be multiple messages with different type. Please respond it. In that message queue, there may be multiple messages. There may be multiple messages with different type. So, which message you want to read, you need to mention here. which message you want to read from the message queue, you need to pass it. Now I hope this part, this part we are opening, as well as if not, they're creating it. Next is MSG RCV. Will agree? This MSG RCV is useful for receiving purpose. This MSG RCV is useful for receiving purpose. First argument is ID. Second argument is address of the structure. Third argument is size of the structure. Fourth argument is that input which we are taking from the command line. Fourth argument is that input which we are taking from the command line. The type of the message. Fifth argument is for the time being. Fifth argument is for the time being. Fifth argument is for the time being. 0. What is the fifth argument name here? Can you tell me what is the fifth argument name? What is the fifth argument name? Can you say flags? The flags we are going to put as a 0. So today, little bit more properties about receiver section we need to discuss it. So what is the today's discussion? Little bit more about receiver section, and one more function, MSG CTL function, we need to discuss it. Again, today, little bit more discussion on the receiver part. Apart from that, we need to discuss one function called MSG CTL. Apart from that, we need to discuss one function called MSG CTL, message control. Is this point is clear, whatever we are going to discuss in a today's session? So type 3 in the chat box. If this part is clear, type 3 in the chat box. Whatever we are going to discuss in a today's session, type 3 in the chat box. Okay. So I'll open one function. I'll observe this. Just a minute. Suppose these are the queue positions. These are the message. This is the queue position. This is the message type. This is the message. So what is the first message in this message queue for this example? In this example, what is the first message? First message is vector. What is the type of the message? 3. What is the second message? India. What is the type of the message? 2. What is the third message? Bangalore. What is the type of the message? 3. What is the fourth message? Hyderabad. What is the message type? 1. Fifth message, Chennai. Message type is 2. Sixth message, Pune. And message type is 4. Will you agree? Now can you tell me, in this example, how many messages are there in this queue? In this example, how many messages are there in this queue? Okay. How many messages are there in this queue? There are 6 messages are there. Let's assume it. 6 messages. Now observe, I am talking about in MSG RCV. In MSG RCV, I am talking about 4th member. Again, in MSG RCV, I am talking about the 4th member. What is the name of the 4th member? In MSG RCV, I'm talking about the fourth member. What is the name of the fourth member in MSG RCB? I'm not talking about message BE9S8. I'm not talking about a fourth message. I'm talking about in this function the fourth member. Can I say fourth member is long MSG TYP? Fourth member is long MSG TYP. Will you agree? BE9S8. I'm talking about a fourth member of this MSG RCB function. MSG RCB function. Fourth member is long MSG TYP. Now observe, if that fourth member is, if MSG TYP is 0, then the first message from the queue is removed and returned to the calling process. Very important point. If MSG TYP is 0, means if I type /RCV 0, if I type /RCV 0, in this case, what the kernel will do? In this case, what the kernel will do? Irrespective of the message type, the first message it will give us. Very important point. If MSG RCV, MSG TYP is 0, which is the fourth argument in the MSG RCV. In the MSG RCV, I'm talking about the fourth argument. If you pass it, that fourth argument is 0. Irrespective of the type of the message, the first message kernel will give us. Irrespective of the type of the message, the first message the kernel will give us. Is this point is clear? If MSG RCV, in MSG RCV, if the fourth member is 0, irrespective of the type of the message, the first message the kernel will give us. Irrespective of the type of the message, the first message the kernel will give us. Observe. So /snd 3 vector. /snd to India. /snd 3 Bangalore. /snd 1 Hyderabad. /snd 2 Chennai. /snd 4 Pune. Now can you tell me how many messages are there in this message queue? Can you tell me how many messages are there in this message queue now? How many messages are there in this message queue? Will you agree? 6 messages. How can I see? IPCS-Q. Will you agree? There are 6 messages are currently available. As per the material I'm discussing here, as per the material I'm discussing here, so that later you can refer that. Again, as per the material example I'm discussing here, so that after the class you can refer it. There are 6 messages are there in the message queue. There are 6 messages are there in the message queue whose key number is 3 currently. In these 6 messages, what is the first message? Now tell me, if I might have written /RCV 4, can you tell me which message the kernel will give us? If I write /RCV 4, can I say kernel will give us this message to us? /RCV 2, which message the kernel will give us? /RCV 2. It will give us India, not Chennai. Why? Because Q, first in, first out. BE9A3. Is it clear? It will give India, not this one. Now can you tell me, if I write /RCV 0, that's what we are talking here. If I write /RCV 0, irrespective of the type of the message, the kernel will give us the first message. Irrespective of the type of the message, the kernel will give us the first message. Observe here, if MSG TYP is 0, then the first message in the queue is removed and returned to the calling process. Then the first message is given to the calling process. Observe, if I write /RCV 0, can I say the first message the kernel given us, irrespective of the type of the message, first message the kernel given us? Will you agree? The first message the kernel is given us. Now, if you agree with this statement, type 1 in the chat box. Irrespective of the type of the message, the first message the kernel will give us. If you mention the type of the message in the receiver section as a 0. If it is greater than 0, can you read this point? If MSG TYP is greater than 0, the first message in the queue whose M type is equals MSG TYP is removed and returned to the calling process. Like if I write /RCV 2, suppose there are two messages in the queue with the same type, which message it will give? There are two messages with the same type. Which message it will give us? The first message. So, if MSG TYP is greater than 0, then the first message in the queue, which is equals to this, it will return it. It will be read. So, in this example, with message type 2, which message is there? In this example, with message type 2, what is the first message? India. So that message the kernel will give it to us. I need to tell you, this is like internally linked list only. Once the kernel is given the message to us, the kernel will delete that message. The kernel will delete the message in the message queue. Is the second point is clear? If it is greater than 0, second point is clear. If it is greater than 0, okay. Third point, let's see. If it is less than 0. Third point, if it is less than 0. If it is less than 0, then the first message of the lowest M type less than or equals to absolute value of MSG TYP will be removed and returned to the calling process. Read this third point. Very carefully. If MSG TYP is less than 0, treat the waiting message as a priority queue. The first message with the lowest M type less than or equals to the absolute value of MSG TYP is removed. What is the M type I mentioned here? Suppose /RCV. Suppose if I type -3. Can anybody tell me what is the absolute value of -3? Can anybody tell me what is the absolute value of -3? What is the absolute value of -3? Can I say it is a 3? So in this case, which message it will receive? If any message with type 1, type 2, type 3. In this 3, which is the lowest type? In this 3, which is the lowest type? Can I say 1? So in this case, what happens is this can read message of type 1, 2, 3. It will start from the lowest message type. Lowest message type is Hyderabad first, second is the India, third is the second is the Chennai, third is the vector, and the last one is the Bangalore. Meaning is, if you provide a negative number here, so absolute value of this negative number is 3, less than or equals to 3, whatever the type of the messages is there, in that which is the lowest type, that message the kernel will give us. Suppose there is no message with type 1, then suppose at that moment there is no message with a type 1. Can you tell me which one it will give? Suppose there is no message with a type 1. Can you tell me which message it will give us? 2. But with a type 2, there are 2 messages are there. Which one it will give us? With a type 2, there are 2 messages are there. Which one will give us? The first in that. Which one will give us? The first in that. All of you are getting the point? All of you are getting the point? So what I will do is, let's experiment this. Let's experiment this here. Let's experiment this here. Now what I will do, /RCV /RCV 3 minus 3. Which message is given us? /RCV minus 3. Which message is given us? Hyderabad. Why? Because you mentioned minus 3. When you mention minus 3, so absolute value of minus 3 is 3, less than 3 is 2, that then less than is 1. In this, if any message with the lowest type, it will give us. Suppose with that type, if multiple messages are there, then suppose with that lowest type, if multiple messages are there, then suppose with that lowest type, if multiple messages are there, then if that lowest type, if multiple messages are there, then yeah, first message it will give us. Then the first message it will give us. I hope with this you understood these 3 conditions. First condition is, if MSG TYP is 0, if you pass the fourth argument is 0, irrespective of the type of the message, the first message the kernel will give us. Irrespective of the type of the message, in the queue, which one is the first message the kernel will give us. If you pass MSG TYP is greater than 0, with this type, if any messages is there, so that message it will give us. With this type, if 2 messages are there, of multiple messages are there, in that first message the kernel will give us. If you pass negative number here, so absolute value of that is this one, and lowest type is in this messages, lowest type, in that the first message the kernel will give us. These are the 3 different conditions. These are the 3 different conditions in this receiver section. In this 3 different conditions in the receiver section. This is one important point. Second important thing is, we need to talk about a flags also. There are 2 flags are there. There are multiple flags are there. One flag is IPC underscore no wait. IPC underscore no wait. If you use in the receiver section this flag, it will not wait. IPC underscore no wait. If you use this flag in the receiver section, so what happens? Performs a non-blocking function. Observe, normally, if no message matching with MSG TYP in the queue, MSG RCV will block. Yes or no? Normally, if you put flag as 0, if there is no message with matching with MSG TYP, if there is no message matching with MSG TYP, will you agree it will block? MSG RCV function will block. Yes or no? MSG RCV function will block. If you use this flag, what happens is it will not block. If you use this function, what happens is it will not block. Is this flag is clear? Is this flag is clear? If you use this flag, receiver function will not block if there is no message with that MSG TYP. It will not block if there is no message with MSG TYP. There is no message with MSG TYP. Now, if you want to experiment this, let's see. If you want to experiment this, what I will do, first I will remove all the, just a minute. First I will remove all the messages. Can you tell me how to remove all the messages now? Can you tell me how to remove all the messages? Just /RCV 0. 0 means the first message it will give us. The first message it will give us. The first message. Now I hope every message went. Now what I will do is p2.c. What is the flag? What is the flag? In the receiver section, what is the flag? What is the flag? IPC underscore no wait, is it? IPC underscore no wait. If, can you guess upon failure what it will do? Upon failure what it will do? What it will return? If it is less than 0. The error. MSG RCV. No need to further proceed. Return. Normally, if you don't use this flag, if there is no matching message with this type, can I say it will block? If there is no message matching with this type, it will block. But it will not block now. It will no wait. Now let's see. cc p2.c -o RCV. Now can you tell me any messages are there in the message queue now? IPCS-q. Is there any messages are there in the message queue currently? Is there any messages are there in the message queue currently? No. Now observe /RCV2 means I want the message in the message queue with a type. I want the message in the message queue with a type. I want the message in the message queue with a type. I want the message in the message queue with a type 2. See, is it blocked? Is it MSG RCV is blocked or is it failed? Can you tell me? In this, the MSG RCV, is it blocked or is it failed? Will you agree? It is not blocked. It is failed. Is this flag? Is this flag? Is it clear? IPC underscore no wait flag. Is this flag is clear? Type C in the chat box. If you use this flag, what happens? If it is clear, type C in the chat box. Okay. Next flag. What is it? What is the next flag? What is the next flag? MSG underscore accept. MSG underscore accept. This flag has an effect only if MSG TYP is greater than 0, in which case it forces the complement of usual operation. Complement of usual operation means, now can you tell me, when you write /RCV3 means, will you agree you are expecting the message, the first message in the queue whose M type is 3? Will you agree? In this case, you are expecting the first message in the queue whose M type is 3. But if you use this flag, reverse process. So then what happens is, that is the first message from the queue whose M type is not equals to MSG TYP is removed from the queue. The first message, if you use 0 here, the first message in the queue whose M type is 3 equal to 3 it will give. Yes, sir. But if you use except flag, except this remaining messages, in that remaining messages the first message it will give us. Except that remaining messages, in the remaining messages the first message it will give us. Getting the point? If you want, while practicing you can experiment this. Now can you tell me, if I write here ./RCV3, so what message it will give us? If I write, suppose these are the messages in the message queue and their positions, first, second, third, fourth, fifth, sixth. So which message it will give us? If I write ./RCV3 and flag as 0, ./RCV3, the flag as 0, then which message it will give us? First message with that type. The first message it will give us. Will you agree? If I write flag as MSG accept, if I set the flag as MSG accept, then if I set the flag as MSG underscore accept, except 3, in the remaining messages the first message, except 3 in a remaining messages the first message. What is the first message in the remaining messages? The kernel will give us this message, India. Except 3 in a remaining messages, the first message it will give us. Except 3 in a remaining messages, the kernel will give us the first message. Except 3 in a remaining messages, the kernel will give us the first message. Is that point is clear? Type C in the chat box. If you put except flag, except that MSG TYP, remaining messages, in the remaining messages, the first message kernel will give us. The first message the kernel will give us. If you don't use except flag there, so with that type, any message is there, so in that the first message it will give us. With that type, if any message is there, the first message the kernel will give us. With that type, any message is there, the first message it will give us. Now suppose if I write ./RCV4, suppose if I write ./RCV4, if I write MSG RCV4 flag is 0. Now tell me, in MSG RCV flag as 0. Can you tell me which message it will give us? Normally it will give this message, Pune. If you use except this, in a remaining messages, which message came first? Except this, in a remaining messages, which is the lowest type? Which is the lowest type? I think 1. Let's experiment this. What is there in that? Let's experiment this thing here. Once again, I will send the messages here. Once again, I will send these messages. So first let me check it out. I don't know, I can use that except flag or not. Vi p2.c. So let's use this except flag. What is a flag? Can you tell me? MSG underscore EXCEPT, is it? Just wait. MSG underscore EXCEPT. First of all, I need to cross check it. Is this flag is supporting or not? Some of the versions this flag will not support. So MSG except flag is not supporting. And if you are getting this point, MSG except flag is not supporting. If it is supporting, what happens? You need to see. So the first message from the queue whose M type is not equals to MSG type TYP is removed from the queue and returned to the caller. All of you understand this? This flag is only effective if MSG TYP is greater than 0, in which case the fourth complement of usual operation, that is the first message from the queue whose M type is not equals to MSG TYP is removed. The first message in the queue whose M type is not equals to MSG TYP, not equals to MSG TYP. Now can you guess what happens in this case? Not equals to MSG TYP. So if I write ./RCV 4 not equal to this, which is the first message? Which is the first message? Which is the first message? That it will give us. Tomorrow I will show you there is some macros we need to add it. There is some macros we need to add it to use that MSG except flag. There are some macros we need to add it. So to use that. So for the time being, theoretically you understand this. If possible, tomorrow I will show you practically. Is that is clear? A3. The first message in the queue, it will give us. Okay. So this is about the receiver section. This is about the receiver section. The receiver and full duplex communication. Now in this program, in this example, they mentioned full duplex communication using the message queue. Full duplex communication using the FIFO, what we did? I don't know, you able to recollect it or not? When in a full duplex communication in a FIFO, parent and child and parent we taken. How many FIFOs we taken here for full duplex communication? How many FIFOs we taken to achieve the full duplex communication using the FIFO? Can I say 2 FIFOs? Parent is writing into F1 FIFO. This child is reading from the F1 FIFO. This parent is writing from the F2 FIFO. This is reading from the F2. We taken the help of 2 FIFOs there to achieve the full duplex communication. Now here, now observe, to achieve the full duplex communication here, they're not taken the 2 different message queues. They taken only one message queue. Whose type is? They taken only one message queue. Whose type is 2. Now again, if fork double equals to 0, who will execute the body of the if? Fork double equals to 0, who will execute the body of the if? Who will execute this portion? Who will execute the body of the if here? Can I say child will execute the body of the if? Now, can you tell me child is waiting in this message queue with what type of message it is waiting? Child is waiting with what type of message? Which message it is waiting? Which message type? 3. Now tell me, in this, parent is sending a message with which type? Parent is sending a message with which type? 2. So when the parent is sending one message with type 2, can I say here this child is waiting for type 2? And this is sending with a type 3. This is receiving. Again, it may be a little bit confusion here. These things are observed here. This diagram will be more clear. Parent is scanning the data from the keyboard, sending the message to the message queue with, in this left hand side, parent is scanning the data from the keyboard. After scanning the data from the keyboard, parent is putting the data into the message queue with the type. Parent is putting the data into the message queue with the type 2. Whereas left hand side child is waiting for the message with the type. Left hand side child, parent is waiting for the message with the type. Child is waiting message with the type 3. In the right hand side, child is waiting for with the type 2. Parent is sending the with type 3. Now my question is here, parent 2 in the right hand side sending the message with which type? Parent 2 is sending the message in the right hand side with which type of the message? 3. In a left hand side, child 1 is reading the message, waiting for the message with which type? Type 3. Now my question is, in this full duplex communication, is the 2 message queues are used or only 1 message queue is used? In this full duplex communication, is the 2 message queues are used or only 1 message queue? Only 1 message queue. But only 1 message queue is used. But only 1 message queue is used. But with different types. Only 1 message queue is used, but with different types. So there is no need of 2 message queues to achieve the full duplex communication here. There is no need of 2 message queues to achieve the full duplex communication here. No need of 2 message queues. If this diagram is clear, so type C in the chat box to achieve the full duplex communication. This is the procedure. If this diagram is clear, type C in the chat box. Now will you agree? In this, parent is in a while one loop, child is in a while one loop. In this, parent is in a while one loop, child is in a while one loop. Child is in a while one loop, parent is in a while one loop. Will you agree? Process manager will give the separate time slice to the child and separate time slice to the parent. Process manager will give the separate time slice to the parent as well as the separate time slice to the child. Now here also the same thing. So this is the way This is the way the full duplex communication is achieved. So this is the way the full duplex communication is achieved. Next function is, what is the next function? What is the next function? MSG-CTL. Next function is message control. Try to copy the prototype of this MSG-CTL. Next function is MSG-CTL, message control, to do the control operations. Next function is MSG-CTL. What is the first argument of this MSG-CTL? What is the first argument of this MSG-CTL? ID. What is the second argument? This is very important argument. Command. Second argument is very important argument, that is command. What is the third argument? Can you tell me what is the third argument? You need to pass what? You need to pass address of a structure variable. Third argument, you need to pass the address of a structure variable. Third argument, you need to pass the address of the structure variable. What is the name of the structure? Third argument, we need to pass the address of the structure variable. What is the name of the structure? MSQID_DS. All of you are observing? The name of the structure is MSQID_DS. Third argument is MSQID_DS. So my question is, MSG-CTL is useful for creating the message queue, yes or no? MSG-CTL is useful for creating the message queue, yes or no? MSG-CTL is useful for creating the message queue, yes or no? No. MSG-CTL is useful for sending the message into the message queue, yes or no? MSG-CTL is useful for sending the message into the message queue, yes or no? No. MSG-CTL is useful for receiving the message from the message queue, yes or no? No. Then what is the purpose of this MSG-CTL? The purpose of this MSG-CTL is not for sending the message, not for receiving the message. The purpose of this MSG-CTL is to do some control operations on the message queue. To get some information, to set some informations using this MSG-CTL. Suppose if use IPC_RMID. If you use the command as IPC_RMID. Now if I write MSG-CTL ID IPC_RMID, 0. All of you copy this line. All of you copy this line. MSG-CTL, first argument is the ID. The second argument is IPC_RMID. Second argument is IPC_RMID. The third argument I am passing as a null pointer. So in this case, what happens? Can you guess? In this case, what happens? Can you guess? Can I say this message queue whose ID is this is removed from the kernel space? The message queue whose ID is that it is removed from the kernel space. I don't know, yesterday you observed or not, to remove the message from the message queue, yesterday you observed or not, there is one command we used. Can anybody tell me what is the command yesterday we used to remove the message from the message queue? What is the command we used to remove the message from the message queue? What is the command yesterday we used to remove the message from the message queue? You agree the command is IPCRM. The command yesterday we used to remove the message from the message queue is IPCR. So not only through command, through function also you can remove the message from the message queue. Again, not only through command, through function also you can remove the message from the message queue. So if you want to remove the message from the message queue, which function you need to use and which command you need to supply there? Listen the statement. If you want to remove the message queue through function, which function you need to use? If you want to remove the message from the message queue, if you want to remove the message from the message queue, if you want to remove the message from the message queue, which function you need to use? Which function you need to use? MSGCTL. And in MSGCTL, what is the second argument you need to pass? In MSGCTL, what is the second argument you need to pass so that you can remove that message queue? So that you can remove the message queue, IPC underscore RMID, so that it will remove the message queue. Is that point is clear? First usage of this MSGCTL. Second usage, IPC underscore STAT. Second usage, IPC underscore STAT. Suppose if I write MSGCTL ID IPC underscore STAT address of V. What is that V here? What is the type of this V? Can you tell me? Can I say the type of this V is this structure variable? I don't know, you remembered or not, when we started with a signal onwards, there are some structures we observed. One is sig action structure. One is R limit structure. One is stat structure. Suppose you want to get information about the file. So what you will use? Stat, file name, address of V. Will you agree? What is the type of the V? Struct, stat, V. Type of the V is this one. So that who will fill these members of this structure? Who will fill the members of this structure? Who will fill the members of this structure? Suppose I want to get the information about the file using the stat function. First argument I am passing as the name of the file. Second argument I am passing the address of the structure. My question is, who will fill this structure? Can I say file manager will fill this structure? Will you agree? The file manager will fill this structure. Similarly, if you want to get the information about the message queue, you can use MSGCTL. First argument is the ID. Second argument is IPC underscore STAT. Third argument is address of a structure. Which structure? Struct MSQID underscore DS structure. What is the third? Struct MSQID underscore DS structure. MSQID underscore DS structure. Is that point is clear? Is that point is clear? So you can get all the information about the message queue into that structure. So there are so many informations are there. Number of bytes in the message queue, number of messages in the message queue, PID of the last message sent, PID of the last message received. All these messages, all these informations, you will get it if you use IPC underscore stat. Basically, this function is not normally used. This function is not used to send, not used to receive. Just you used to do some control operations like removing the message queue, like getting the message queue information. So for that purpose it is used, but normally it is not used for sending purpose, not used for receiving purpose. Is it clear? So next is, as all of you might have observed, the disadvantage of this message queue. So message queue is called as one of the slowest IPC mechanism. Again, the disadvantage of this message queue is it is called as the slowest IPC mechanism. Why it is called as the slowest IPC mechanism? All of you know that here, all of you know that it is, why it is called as the slowest IPC mechanism. All of you know that internally the kernel will need to maintain a concept of linked list operations. For this IPC mechanism, if two processes are communicating with message queue, so message queue service is slower. Why the message queue service is slower? Very simple, because internally the message queue manager need to maintain the linked list. Again, internally the message queue manager need to maintain the linked list. Will you agree? It need to maintain the add function. It need to maintain the search function. It need to maintain the delete function. Will you agree? In a linked list operations, you might have done these functions, right? Add function and what you call search function and delete function. So this type of things internally the manager need to do. This type of things internally the manager need to do. Is that point is clear? So that's why it is called as the slowest IPC. The second disadvantage, if you see here, we are using the key rather than the file name. So one more negative point about this IPC mechanism. In this IPC mechanism, we are using the key concept, not the name concept. So like this, some disadvantages are there. So first, to overcome this, there is one more IPC mechanism. What is that IPC mechanism? Which is called as the fastest IPC. To overcome that, one more IPC mechanism that is called as a shared memory. Is it clear? To overcome that slower and all other things, one more IPC mechanism that is called as a shared memory. Note down the functions involved in this IPC mechanism. Note down the functions involved in this IPC mechanism, shared memory. First function is SHM get. Second is SHM 80. And third is SHM DT. And fourth is SHM CTL. The functions involved in this IPC mechanism. Are the four functions. One is SHM get, SHM 80, SHM DT, and SHM CTL. Note it down. SHM get is useful for creating and opening the shared memory segment. Again, SHM get function is useful for creating as well as opening the shared memory segment. SHM get function is used to create as well as opening the shared memory segment. SHM 80 is useful for attaching shared memory segment to a process. SHM 80 is useful for attaching the shared memory segment to a process. SHMDT is useful for detaching shared memory segment from the process. Again, SHMAT is useful for attaching the shared memory segment to a process. Again, SHMAT is useful for attaching the shared memory segment to a process. SHMDT is useful for detaching the shared memory segment from the process. And SHMCTL and SHMCTL. Can you guess what is the use of this? Like MSGCTL. Like MSGCTL. What is the use of SHMCTL? Like MSGCTL. What is the use of SHMCTL? Yes, to do some control operations on shared memory segment. Again, these are the 4 functions in this IPC mechanism. One is SHMGET, and another one is SHMAT, and another one is SHMDT, and another one is SHMCTL. One is SHMGET, and another one is SHMAT, and another one is SHMDT, and another one is SHMCTL. SHMGET is used to create and opening the shared memory segment. SHMAT is used to attach the shared memory segment to a process. SHMDT is used to detach the shared memory segment from the process. SHMCTL is used to do some control operations. Now my question is, if any process is allocated a memory using the malloc, can another process access that memory? If one process is allocated a memory, dynamic memory using the malloc, another process can access that memory, yes or no? If one process is allocated a memory using the malloc, dynamic memory, suppose the P1 process is allocated a dynamic memory using the malloc, P2 process, can it access it or not? Answer is, it cannot access it. P2 process cannot access it. But if one process is created a shared memory, another process can access it. If one process is created a shared memory, another process, can it access it? If one process is created a shared memory, another process, can it access it? Okay, if one process is created a shared memory, another process, can it access it? Answer is yes, another process can access it. Are you getting the point? If one process is allocated a dynamic memory, another process cannot access it. But if one process is created a shared memory, another process can access it. So I'm going to discuss that. Now mkdir, just a minute. mkdir SHM shared memory cd SHM and cp /header.h/. So what I did, I created one folder called SHM to give a demo on this IPC. I created one folder called SHM. In that SHM, that header.h, I copied it. Now what is my target is, I'm going to create 2 processes, P1 process and P2 process. P1 process is going to write the data into the shared memory. P2 process is going to read the data from the shared memory. Again, P1 process is going to write hello world into the shared memory. P1 process is going to write hello world into the shared memory, whereas P2 process is going to read that hello world from the shared memory. Is that point is clear? What I'm going to discuss, what I'm going to write? I'm going to write one small example program to understand this concept. There are two programs I'm going to write, P1.c and P2.c. P1.c program is going to put the data into the shared memory segment, hello world data, whereas P2 process is going to read the hello world data from the shared memory segment. Okay. Now let's start the function man shm get. Copy the prototype of shm get here. Copy the prototype of shm get. How many arguments you need to pass? How many arguments you need to pass? You need to pass 1, 2, 3 arguments, and it returns an ID. Okay, shm get, you need to pass the 3 arguments. shm get, you need to pass the 3 arguments. First argument is the key. Second argument is the size. And third argument is the flag. First argument is the key. Second argument is the size. Third argument is the flag. What are the header files we need to include? Here? sys/ipc, sys/shm. So sys/ipc and sys/shm. I think sys/ipc is already there, and let's check it out. Shm is there or not. I hope in this header file which I copied from somewhere, shm is also might have there. Is there? Shm is there? sys/shm is there or not? Sys/shm is there or not? Answer is yes, it is there. Now observe P1.c. This program, what is the job of this program? This process need to send hello world to shared memory. This process need to send hello world to shared memory. This process need to send hello world to shared memory. Okay. Now hash include header.h void main int id. This concept is something related to the message queue only. id is equals to shm get. I given the key as a 3. I given the message queue size as a 50 bytes. IPC underscore CRE80 R with 0664. Okay, now tell me what it will do. If ID is less than 0, then P error shm get. No need to do any further process. So what I'm informing to the SHM get function is, if any shared memory segment with this key, try to open it. If not there with this key, try to create 50 bytes of shared memory. If not there with that key, try to create 50 bytes of shared memory. Now, will you agree? In the last session, whatever the message queue we discussed, every message queue is recognized with one key. Every message queue is recognized with one key. Similarly, every shared memory segment is also recognized with one key. Again, how every message queue is recognized with a key. Similarly, shared memory segment is also recognized with one key. How a message queue is recognized with a key, in a similarly, shared memory segment is also recognized with one key. What is the key here I provided? What is the key I provided here? What is the key I provided here? Can I say key S3? Suppose with that key already shared memory segment is there, then suppose with that key already shared memory segment is there, then you will get an ID. If not there, create and you will get an ID. Again, with that key, if already shared memory segment is there, with the key number 3, if already shared memory segment is there, then you will get an ID as a return type. With that key, if there is no shared memory segment is there, the function will create and you will get an ID. The function will create and you will get an ID. So what is the next step? After creating and after whatever creating or opening, what is the next step? Next step is we need to attach this memory to a process. Then only we can do the transactions. Again, in this IPC mechanism, what is the procedure is? In this IPC mechanism, what is the procedure is? After creating or after opening the shared memory segment, after creating or after opening the shared memory segment, we need to attach that shared memory segment. So what is the prototype of this SHM-80? What is the prototype of SHM-80? All of you copy this. All of you copy this. SHM-80. 1, 2, 3. Return type is void pointer. 3 arguments and return type is void pointer. What is a malloc returns? What is a malloc returns? What is a malloc function returns? Can I say malloc function also returns a void pointer, generic pointer? Will you agree? Malloc function returns the generic pointer. Here also, this function returns a void pointer. Here also, this function returns a void pointer. Will you agree? I'll show you. It will be better. You can easily understand it. I taken one character pointer, character star p. P is equals to SHM-80. First is the ID, second argument is a 0 and 0. Data. Enter the data. Don't worry, what is the zeros there? Scanf percentile s comma p. What is a percentile s format specifier required? What is a percentile s format specifier required? Can I say address? Now what happening is here? What happening is here? we are getting the address of that shared memory segment. We are getting the address of that shared memory segment, and we are putting the data into the shared memory segment. Remaining thing is like a C procedure only. Again, we are getting the address of the shared memory segment. We are putting the data into the shared memory segment. So transmitter program is ready now. CC P1.C -O send. Receiver program is much more simple. P1.C, P2.C, VI, P2.C. In the receiver program, just you need to print the data. Data is equals to %s /n, p. Receiver program is very simple. CC P2.C -O RCV. Now the ./snd, enter the data. Hello. ./RCV. Hello is received. All of you are observing. ./snd. ./snd. I'm sending an hello into the shared memory. So the sending process ./snd is putting the data into the shared memory, and receiver process ./RCV received this. One thing, can you tell me, till now whatever the IPC mechanisms we discussed it, if receiver process receives, kernel will delete the shared memory, delete the data. Once the receiver process receives, can I say kernel will remove the data? Yes, sir. In a pipe, named pipe, in a message queue, whatever the 3 IPCs we discussed. If sender is sending the data, it will maintain in a kernel space. Once receiver receives, it will delete it. Please reply it, yes or no. Once receiver receives it, it will delete it. But in this IPC mechanism, observe, when even though receiver read the data is not deleted. Even though receiver reads the data is not deleted. Now observe, ./snd transmitter is transmitted, receiver is received. Transmitter is transmitted, receiver is received. Like this, your shared data, where transmitter is putting the data and all the receivers are receiving the data. Is this example is clear? So what is the functions involved? What are the functions involved in the transmitter side, in the receiver side? What is the functions involved in the transmitter side, in the receiver side? Transmitter side is SHM, get, SHM 80, and remaining things are printf and scanf only. In the receiver side, SHM get and SHM 80. So what I will do is, I'll share these 2 programs in the LMS with the today's data. So tomorrow, before coming to the class, once again try to go through these 2 programs. Tomorrow we'll continue this IPC and remaining things we'll discuss it. Is it clear? SHM 80, like suppose you want to send a file in a Gmail. Will you agree you need to attach that file? Yes, sir. So in this IPC mechanism, any process can create a shared memory. If any process wants to write the shared memory, they need to attach it. So what happens in a SHM 80? In a tomorrow session, we'll discuss it. What happens in the SHM 80? In a tomorrow session, we'll discuss it. So without attaching the shared memory, just only simply when you create it, you can't transfer the data into the shared memory. You can't put the data into the shared memory. Again, without transferring, without attaching the shared memory, you can't send the data into the shared memory. SHM-80, what it will do is, it will give us the address of the shared memory segment. SHM-80 is giving us the address of the shared memory segment. So then we are using the C procedure to put the data. A3, is it clear? So tomorrow, many more things about the shared memory, many more properties we'll discuss it. What is the meaning of attaching? What happens when you attach? All these things theoretically tomorrow we need to discuss it. So thank you very much. So tomorrow we'll continue this. I'm going to wind up the today's session.